Hey there, welcome to my YouTube channel. This is Unit 1 Electrostatics, and the topic of discussion for the day is deduction of Coulomb's law from Gauss law. That is, first of all, we will start with the Gauss law, and by following step by step instruction, we will deduce the Coulomb's law from it. That is, we will have to start from the expression phi is equal to closed integral E dot ds is equal to q upon epsilon naught, which is a Gauss theorem. That is, flux coming out of the closed surface is equal to 1 upon epsilon naught times the charge enclosed by the closed surface, or the closed integral of the electric field intensity over a closed surface is equal to 1 upon epsilon naught times the charge enclosed by the surface. We will start our article from this point, and the final result which we have to reach is Coulomb's law. And according to Coulomb's law, F is equal to 1 upon 4 pi epsilon naught q1 q2 upon r square. So we know our starting point and we know where we have to reach. It's r square, so I will put r square over here. So when we know from where we have to start and we know what the final destination is, then it becomes easier for us to discuss the things. As we have to find the Coulomb's law from the Gauss law, that means we have to start our article from the Gauss theorem, and Gauss theorem could only be implemented if we are having a Gaussian surface. So let us get into the deduction. And first of all, we need is a charge, and I have considered a unit positive test charge. It is not a unit charge, it is plus q charge. And now I need to consider a Gaussian surface. Let us make a Gaussian sphere of radius r. So I'm taking this radius small r. Now the unit positive charge or a positive charge always indicates the electric field leaving the surface, and such that this electric field line leave a surface perpendicularly. That means if this line is representing electric field, the direction of electric field, then it will leave this surface perpendicularly normally. So this is the property which we already have discussed earlier. And now I need to consider a small area vector. And how I could consider a area vector? From this Gaussian surface I will consider a very small surface. So let us say this is a very small surface having a surface area ds. So in order to make area vector, what we have to do, we have to take a vector which is perpendicular to this small area ds area and is acting away from it. So this line which is perpendicular to ds, that is small area, and is pointing away from the area becomes area vector. So this is ds vector. Here electric field line is leaving a surface normally, that is it is making an angle of 90°, and the area vector ds vector is also leaving a surface perpendicularly, that is it is also making an angle of 90° with the considered small surface. Therefore angle between e vector and ds vector is 0°. So this is the first foremost important point which we need to consider. So according to Gauss theorem, we have closed integral E vector dot ds vector is equal to q upon epsilon naught, because this charge q, its position is not mattering at all, because we know that we only need a Gaussian surface, and Gaussian surface could be of any shape or any size, but we always choose that Gaussian surface over which surface integral is easier to calculate. Therefore we are having closed integral E vector dot ds vector is equal to q upon epsilon naught. Now we will move further into this. As I said that ds vector is making an angle of 90° with the surface, E vector is leaving the surface normally, therefore both the vectors E vector and ds vector are parallel vectors, and between the parallel vectors the angle between them is 0°. So here we have closed integral E ds cos 0 is equal to q upon epsilon naught, and we know cos 0 is 1. So therefore closed integral E ds is equal to q upon epsilon naught. Now The value of electric field intensity is constant because we are not going to change the charge and the charge will remain the same. So therefore electric field intensity because of that charge will also remain same. So taking the constant term outside the integral, we have E closed integral ds is equal to q upon epsilon naught. So now if I have divided this Gaussian surface into infinite number of small surfaces, each of area ds, when we will integrate, that means we will add up all these infinite small surfaces, we will come out with a spherical surface. So total surface area of a sphere is 4 pi r square. Therefore I can say E into 4 pi r square because the Gaussian surface is considered to be of radius small r. Therefore I have taken over here small r. 4 pi r square is equal to q upon epsilon naught. And from this point we have E is equal to 1 upon 4 pi r square q upon epsilon naught. And on arranging up this term, we have E is equal to 1 upon 4 pi epsilon naught q upon r square. So let us take it as our equation number 1, that is the value of electric field intensity. But the final result which we wanted to reach was to find the value of force, that is to reach the Coulomb's law, that is force is equal to 1 upon 4 pi epsilon naught q1 q2 upon r square. So let us suppose that at this point at distance small r from the center of the sphere, we are having a test charge q naught placed over here. So it is just a consideration, it is just an imagination that we have just put a q naught charge over here, and let us now suppose that plus q charge is placed at center, so that the distance between plus q and q naught charge becomes r, that is equal to radius of the sphere. So now the charge which is placed at this point q naught will experience a force of repulsion because of plus q charge placed at the center of the sphere. Therefore we know F is equal to q naught E. So since E is equal to F upon q naught, or F is equal to q naught E, therefore from equation number 1 we can substitute the value. So mark it as equation number 2. And we will be having F is equal to q naught multiplied by 1 upon 4 pi epsilon naught q upon r square, and rearranging we can get 1 upon 4 pi epsilon naught q naught upon r square, which is a Coulomb's law, that is F is equal to 1 upon 4 pi epsilon naught q naught upon r square. But if I want to write it in a very general form, instead of writing it in the form of q and q naught, what we will do, let q is equal to q1 and q naught is equal to q2, we can change our general expression of Coulomb's law as 1 upon 4 pi epsilon naught q1 q2 upon r square. So finally we started solving our article from the Gauss theorem. We considered a charge which is enclosed by a closed Gaussian surface. We started our article from the definition of Gauss law, that is closed integral E dot ds is equal to q upon epsilon naught, and finally we reached to the result, that is F is equals to 1 upon 4 pi epsilon naught q1 q2 upon r square, which is a Coulomb's law. So we have deduced the Coulomb's law from the Gauss law, and I hope you have understood this article, and if yes, then do not forget to press like, subscribe and share button.